during this class. I did get the lesson up from yesterday, and I will try to do the same thing tomorrow when you're gone again, because I know you're doing your performance task tomorrow if you're here today, right? Okay. So, again, we have another set of formulas. These ones are called the half angles. Before we had the double angles, right? So the double angle told us, and that's what we did on Monday, was we did double angle on Monday. The double angles gave us 2 times something, right? Half angle means I'm going to do something divided by 2. Okay, so if I see something divided by 2, I know I'm applying the half angle formula. These are the 3 different formulas. Notice tangent has 2 different ways we could use the formula. They all have cosines in them for the most part. All right, I'm not going to go through each one individually because we're just going to look at the chart for our formulas. Okay? All right. So, here we go, applying the half angles. Oh, wait. There's only 3 of them there. But I have to do all 6 here. How am I going to get these last 3? We're going to use a reciprocal identity, right? So, that's what we're going to deal with for the last 3. So, the first 3 are where the real work really is, and the last 3 we just flip them. Okay? All right, so I'm going to start with A. They gave us the triangle and gave us all of its parts. How nice. Okay, although it's a 3, 4, 5, we could have figured that out on our own. Okay. All right, so all I'm going to do is apply my formulas. So I got to apply the cosine formula first. There's a plus minus out front. What comes next in the formula? Square root. Notice it's divided by 2. The black spots are flies, not negative signs, okay? Or periods, okay? You guys, most of you aren't looking at the big screen, so it doesn't really matter. We've got 2 black spots on the screen this morning. All right. What? Yeah, ew, yeah. 1 plus. It's better than the bug we killed the other day, though, so. All right. We need the cosine of that triangle. So what's the cosine of this triangle? 4 over 5. Okay, now, a better name for 1 is going to be what? 5 over 5. Okay, so let's see what we can do with that. It's going to be ugly. Okay, there's no way around the ugly today. So what is 5/5 plus 4/5? 9/5. I'm going to do something at the same time. I'm going to get rid of that fraction at the same time. So to get rid of the double fraction, what do I do with the denominator? Flip and switch to multiplication. Do you see how that's better than me doing the double fraction again? Okay. All right, so let's multiply across the top and across the bottom. So across the top, what do we get? 9. And on the bottom? 10. What's the square root of 9? 3 over square root of 10, right? Okay. I got to rationalize that. Actually, before I rationalize it, since I know I've got to do a flip here, shouldn't I flip it first? Which one is that going to be the flip of? The secant, the cosecant, or the cotangent? Secant. So I'm going to go ahead and flip it right there, so I get that taken care of. And then I'm going to do my rationalizing so my paper doesn't explode because Mrs. Ballard didn't put any magic dust on it. So it'll explode this time. On the homework, I put some magic dust on there for you, right? Okay. All right, so there's A. Let's do B. Okay, so B is the sign. So I'm going to use this. It's a similar formula. I got a plus minus and a square root. What are we dividing by in the denominator? 2 again. Okay, and then what number is first here? 1. And is it a plus or a minus in the sign formula? Minus. Okay, and then what is the actual sign of that triangle? 3 over 5. Interesting. I wrote down the wrong thing last year. Oh, that's right. We have to put the cosine. I said the wrong thing. We have to put the cosine. I did it right last year. All right. The cosine in the formula is 4/5, right? All right. So again, what am I turning this 1 into? 5/5. All right. So let's see. What is 5/5 minus 4/5? 1/5. And I'm going to do the same thing I did last time. I'm going to switch to flip and multiply. So we get plus or minus the square root of what? 1/10, which is really 1 over the square root of 10. Shouldn't I flip there before I rationalize? What is it? Which one should I put it into, the cosecant or the cotangent? Cosecant. So I'm going to flip there, square to 10. If you really want the over 1, great. And then we're going to do our little rationalizing step, which hopefully we can do in our sleep at this point. And there's what sine is. And I'm going to see if I can squish tangent onto the bottom here. So part C is going here. All right, it does not matter which one of the two formulas we use. We might as well do the one with the cosine on the top. So I'm just going to use the first one. Okay, so it's 1 minus the cosine. What's the cosine of that triangle? 4/5. We've done that like a million times, right? And then now it says on the denominator we got to do the sine of the triangle. What's the sine of the triangle? 3/5. All right, what should I turn that 1 into? 5/5. Okay, what is 4/5 or 5/5 minus 4/5? At the same time, I'm going to flip and multiply the denominator. So I'm multiplying by 5/3. What happens? Cancel, so I'm left with 1/3. And then I also flip that for the cotangent, I get 3. All right, we good with that one? Okay. So the next one is going to change it a bit. We're only doing one of those, right? Because it's just all it is straight applying the formula. Okay, we're supposed to use the half angle formulas to determine the exact values of the sine, the cosine, and the tangent. And it looks like, oh, I'm just going to do one of them on this one. So you could do this for all of them. I'm going to choose to do the sine. When you do your homework, you have to do the sine, the cosine, and the tangent. But again, it's just applying the formula, okay? Since this is a half angle, think about this. I have to turn the sine of pi over 12 into the sine of 1/2 times something. So what would I do if I divided a 2 out of there? What would I get? 6. So it would be 1/2 of pi over 6 is what I'm really looking at. I have to do that, and I need to understand that in order to apply the half angle identity, because isn't this the radian measure that we're going to look at? Not the pi over 12. It should probably be something on the unit circle that we recognize, okay? So what you do probably want is your unit circle, okay? Or your inside cover of your book, which is possibly sitting on your desk there. All right, we're going to apply that half angle formula. We know it's plus or minus. What comes next in the half angle formula? Square root, and then we know there's a 1. We know you divide it by 2. For sine, is it minus or plus? Minus. And then are we finding the sine or the cosine? The cosine. So I need you to go to your unit circle. I need you to find the cosine of pi over 6. Actually, you know what? I wrote that down. Never mind. I was trying to skip too many steps. For our notes, let's write it down. On your homework, if you just want to sub in, you can. Okay, so that way we understand where it came from when you're trying to go back and look at your notes. All right, so what's the cosine of pi over 6? I think somebody said it, right? Square root of 3 over 2. So what's a better name for 1? 2 over 2. All right, so let's see. What is 2 over... Oh, I'm just going to leave it that way, aren't I? 2 minus square root of 3 over 2. And then the denominator I'm going to flip and multiply. So what do I get out of the denominator? What does it become? It would be 4, right? And then what's the square root of 4 for that denominator? 2. Check this numerator out, though. I've got the square root of 2 minus the square root of 3. Notice the square root is under the square root. You're going to see that happen in these type of problems. Okay? It just does it. There's no way to get around it. It's normal. Okay? It is normal for that to happen. Okay? If we really wanted the decimal point, we could put it in our calculator, but we don't want that. We're not going to mess with the decimal points. Okay, you could do the same thing, apply the formula with cosine and tangent, but I'm going to keep going because we're going to see enough applying the formulas. But that's, hopefully they break the angle up for you. If not, you pull the 1/2 out. Okay? All right. So on this one, we're supposed to find the exact values of sine, cosine, and tangent. I'm not, and it says specifically we're using the half angle. We know it's half angle because they're dividing by 2. I'm not going to do all 3 of those. I did sine last time. What do you think I should do this time? Let's do cosine. Okay. We'll do tangent on something else. Okay. Oh, maybe not. Would you guys? I'll do. Okay. So I'll do what you guys want to do. Do you guys want to do cosine or do you want to do tangent? Tangent. Okay. Let's do tangent. Because cosine and sine are really similar, right? Okay. Let's do tangent then. Because I was looking ahead. I think we're going to end up using one of the other ones anyways. All right. So we'll do tangent. We're given the secant. So I'm going to have to do a little bit of work to find some stuff, aren't I? The secant, what's easy to get from secant? Cosine. So I know the cosine of u is going to be what? Negative 2/7. I got to be careful because I know that I'm in, let's see, pi over 2 to pi is quadrant 2, right? So I need a quadrant 2 answer. How am I going to get the sine? Because for tangent I need sine, don't I? It's a good thing we did tangent. How do I get the sine? I got to do the triangle, just like we did yesterday. So you see how it's the same ideas? We're just applying a different formula, okay? The same ideas as what we've done the past week. We just something slightly different formula. All right, that's going to be my u, I guess. I know that cosine is the adjacent over the hypotenuse, so negative 2 over 7. To get that third side, what am I going to have to do? Pythagorean theorem. So negative 2 squared plus, I don't know, we'll go with question mark. You can put x if you want, I guess. 7 squared equals 7 squared. What's negative 2 squared? 4. 7 squared? 49. All right, I got to move the 4 to the other side. How do I do that? What do you get? 45. We're going to take the square root. So let's see. I could break 45 down into 9 and 5, couldn't I? So isn't it 3 square root of 5? Or could I leave it square root of 45? That might be okay. So it's also square root of 45. It just depends on what we have to do with the problem at the end. Okay? So if something was being squared in it, I would leave the square root of 45 and not mess with this thing. Okay? In this case, I probably am going to use the 3 square root of 5. I don't know. We'll see what happens here. All right. So we've got to set up the tangent formula. So we're going to do the tangent of u over 2 equals. All right. I'd say let's just use let's use the second one, the sine u. So let's use sine u over 1 plus cosine u. I'm picking on that one because that's going to leave this radical in the numerator. Wasn't that smart? Okay. If not, I'd end up with a radical in the denominator somewhere, and then I'd have to rationalize later, and I don't want to. I'm going to skip that if I can. All right, so what's the sine of this triangle?
3 squared
over 7. Good. And then we have to do 1 plus, what's the cosine of that triangle that we found? Are we okay for the sine to be positive in quadrant 2? Yeah, sine is positive in quadrant 2. We always got to remember to check that. All right, what should this 1 become? 7 over 7. So I've got 3 square root of 5 over 7 divided by, let's see, what's 7 minus 2? 5 over 7, right? Okay, and then I'm going to flip and multiply by the reciprocal. What's going to happen? And we didn't have to rationalize. We got 3 square root of 5 over 5. I'm really glad you guys picked tangent. Okay. Cosine wasn't so bad because I have the cosine written down here. All right. 14's we're only going to go to 15 today. That means we've only got 2 left, right? 14's short. 15's a little bit longer. Okay. So let's do 14 here. It says use the half angle formulas to simplify the expression. So basically I have to get it back into the half angle formula. If I am adding, go back and look at your half angle formulas. Which one has a plus in the middle of it? Cosine. So I know I'm turning it back into cosine. Because I don't have a plus or a minus, what we do to compensate for that, or because of the plus minus, is we throw absolute value bars around it, and that compensates for the plus minus issue. All right, I have to figure out what goes in here. Remember, this piece here is u divided by 2, so I'm going to take that 4x and I'm going to divide it by 2. So what is it really the cosine of? 2x. So that's what they're looking at for this, to get it back into half angle for this one. Yes. Because of the radical. To undo a radical, we don't know if it's plus or a minus, so that's why we throw the absolute values around it. Okay? It's a picky math thing. If you wrote down the cosine of 2x, I'd probably be happy. Okay? All right. Let's take a look at 15. All right. So on this one, we're supposed to find the solutions of the equation, which means I'm solving it. Just like in double angle the other day, remember we replaced the double angle? I'm going to replace the half angle, which is going to kind of turn it into a mess. All right. So what would I replace this sine x over 2 with? Plus or minus square root. If I heard 1, then what do I put? Cosine. In this case, it's in x's all over 2. Okay. At the same time I'm doing that, because I want to get rid of that radical if I can, I'm going to move the 1 and I'm going to move the cosine. So to move the 1, I would add. To move the cosine, I would subtract. The idea is I'm trying to get, I know I'm going to have to get rid of that radical, so I'm moving that at the same time rather than doing 2 lines of work. All right, how do we get rid of the radical? We have to square both sides. And remember, when we square this side, it means we're going to have to FOIL, because I can't just square the 1 and square the cosine. I have to square the entire thing. All right, so what happens on the left side with the square and the square root?
Cancel out.
They cancel out. So you've got 1 minus cosine x over 2. All right, over here, we have to FOIL. I'm going to switch to a different color, so that way we can see the foiling step. All right, I'm going to just write that next to it so I know that I can look at something when I FOIL. What's 1 times 1? 1, good. All right, and then 1 times negative cosine x is what? And how many of those am I going to have? 2, so I just put a 2 in front of it. And negative cosine times negative cosine is? Cosine squared x. The squared goes on the cosine, not on the x. Be careful. Okay? All right. I would like to get rid of this 2 in the denominator. How am I going to do that? Multiply. So we're going to multiply both sides by 2, which means on the right side, I am distributing a 2 in. So 1 minus cosine x equals 2 minus 4 cosine x plus 2 cosine squared x. All right, in order to solve something, I need to have it equal to 0. So I need to move the 1 and I need to move the cosine. So how do I move the 1? Subtract. So 2 minus 1 is going to be what? 1. Actually, I'm going to put that 1 at the end. Okay, I'm going to rearrange my order at the same time. Okay? You're going to see why in a minute. I'm going to move the cosine. How do I move the cosine? Add it. So negative 4 plus 1 is? Cosine x plus 1. And then this, I haven't written that 2 cosine squared, didn't have any friends, so we're just going to write them down. We've seen this trick before, okay? So I'm going to have to factor it. It's similar to 2x squared minus 3x plus 1. How do I factor something like that? Magic x. Okay, that's where we're going to start. So 2 numbers that multiply to 2 and add to negative 3. Negative 2 and negative 1. Good. Do I need a box? Why? There's a leading coefficient. Okay, so top left-hand corner, we're going to put 2x squared, and in the bottom right, we're going to put bottom right, we're putting the 1, and then from the magic x, 2x, and negative 1x. It's always good to review the factoring, right? Because next year, I just tell you to factor it. I don't teach you how to do it, because Miss Dudley teaches it differently than I do. Okay? All right. 2 numbers that multiply to 2. 1 and 2. Where's my 2 going to go? On the side, and my 1's going to go on the top. How many times does 2x divide negative 2x? Good. How many times does 1x divide negative 1x? Negative 1 times negative 1 is 1. All right, so really what I need to do is I need to apply that to what our current situation is. What am I going to put in instead of x's? Cosines. All right, and could I split it into zero product property at the same time? We all okay skipping that step? So I'm going to go ahead and split it right into zero product property. So I'm going to say 2 cosine x minus 1 equals 0 and cosine x minus 1 equals 0. And I know I'm running out of space there. All right, what do I need to do to move this 1? Add. So I've got 2 cosine x equals 1. And then what do I need to do to move the 2? Divide. So cosine x equals 1/2. All right, I'll come back to that in a second. What do I need to do to move this 1? Add. So cosine x equals 1. This isn't new. We've seen this quite a bit before. Okay? What do I need to do to revert? I need to go to the unit circle. I need to find everywhere where the x value is 1/2. So what radian measures does that happen at? And 5 pi over 3. Good. All right, and then I also need to go to the unit circle, and I need to find where the places where the cosine is equal to 1. Where does that happen? Do I include 2 pi? No, because it's got a parentheses, right? What I get on that part is the bracket where it's the 0, but I don't include the 2 pi. Okay? So those 3 things are your answers. And I think that's enough for today, don't you? Okay, give me a second. I'm going to put up the assignment for half angle.